we have here another example for design requirements of highways. A car having a weight of 40 kilonewton is moving at a certain speed around a given curve, neglecting friction. So tanggalin na ni friction between the vehicle and the pavement and assuming centrifugal ratio of 0.30. So meron tayong centrifugal ratio, V squared over GR is 0.30. Compute the force that will tend to pull the car away from the center of the curve. So mag-skid. If the degree of the curve is 4 degree, compute the speed, kilometers per hour, that the vehicle can maneuver around the curve, and compute the super elevation E if the friction given is at 0.12. Centrifugal ratio is basically CR equal to the given force over the weight of the vehicle. Impact factor is your V squared over GR. Centrifugal ratio, force over the weight of the vehicle. Impact factor, the speed of the vehicle over the acceleration due to gravity times the minimum radius of curvature, or the radius of curvature. First, you're now asked to compute the force that will tend to pull the car away from the center of the curve. Centrifugal ratio, given yung weight ng ating car, given yung ating centrifugal ratio na 0.30. Direct substitution, 0.30 times 40 kilonewton gives us the force that will tend to pull the car away from the center of the curve, which is now 12 kilonewton. On that note, we can simply compute the degree of the curve at 4 degree. Compute the speed on kilometers per hour that the vehicle can maneuver around the curve. Remember, you have your engineering survey in computing the radius of curvature of a simple curve, compound curve, and so forth and so on, whether they are in arch definition or chord definition. Remember, arch definition for highway, chord definition for railway. So using arch definition, we have 1145.916 arch, or the chord definition, 1145.916 over the degree of the curve. The degree of the curve given is at 4 degrees. The radius now is at 286.476 meters. So for us to compute for the impact factor, that is velocity of the vehicle over g times the computed radius. So meron na tayong radius na 286.479 meters. Computing for the impact factor, that is 0.30, parehas the centrifugal ratio, equal to V squared over G times R, 9.81 times 286.479. Gives us a speed of 29.036 meters per second. Convert natin yan sa kph, that is 104.53 kilometers per hour. Ito na ngayon yung ating velocity or the computed speed. With that computed speed, tinatanong naman niya for us to compute now the super elevation E. If the friction between the vehicle and the pavement is 0.12, avoiding skidding. So remember the minimum radius of curvature formula, R is equal to the design speed V squared over 127 if it is kph times the super elevation E plus Fs, or plus F. Minimum radius, or the radius computed, is 286.479 meters. And the velocity identified, or the design speed, is 104.53 kilometers per hour. Then square divided by 127 times E plus 0.12. Given yung friction na 0.12. Ano daw yung E natin? E should be 0.18 or 18%. Which is, remember, our maximum should be between 6 to 12% and a minimum of 2%. So more than 12% yung na-compute natin super elevation. So prone na yan sa accident. By doing so, we have to adjust the super elevation at 12% using exactly 12%. So kung nagbago yung super elevation, magbabago yung ating minimum radius of curvature with the given required design speed. So kailangan nating i-revise yung ating minimum radius of curvature if the friction is at 0.12. Revising minimum radius of curvature if the design speed is 104.53 kph, then squared over 127, the friction is given as 0.12, revised super elevation value of 12%. Recomputing minimum radius gives us the minimum radius of curvature is at 358.482 meters at a design speed between 104 and 112. So, andun yun, no? 0.12, 0.13. So, you can also revise the friction din by interpolation. Okay? Pero, sakto naman sa 104, then 0.12, okay lang yan. Minimum radius is now 358.482 meters. So that's it for Module 1, Unit 2, Design Requirements for Highway. In continuation, this will serve as your second assignment for prelim or second coursework activity involving Module 1, Unit 2. You're now asked to show all the necessary solution or solve the given problem set under the elaborate section and the evaluate section of Module 1, Unit 2, Design Requirements in Highway. Under elaborate, please check your course module, refer to our course module, and the evaluate section, also refer to our course module. Paki-check na lang po lahat, nandun lahat ng problems for your coursework number 2, Module 1, Unit 2. So that will be all for Module 1, Unit 2, Design Requirements for Highways. After which, we'll move now to Module 2, Horizontal Alignments of Highway. So better review your horizontal curves. Bye-bye.